All right, so welcome back to the, I guess, the last part of today's class, because I guess this one's the last topic for time series, and I guess it's something that you might be interested in because we're actually using machine learning now. Like we've been doing a lot of statistical stuff for a while, and as I encourage you to do. But in the end, if you want your project to be sexy, then you probably need to do machine learning. Like AI is like buzzword nowadays. So let's do machine learning in forecasting, right? Okay, so before we even do that, let me try to explain to you, what kind of complication you have to encounter if you were to do time series forecasting using machine learning. Okay, so let me do this. I'm going to draw the data. So let's see. I have from T1, time 1, time 2, time 3, 4, 5, 6, I guess that's enough. Okay, I just write the whole thing. 8, 9, 10, 11, 12, 13. Okay, and then I also have my Y value, right? Something that you want to forecast. I should have written this in advance. Okay. Okay. So in your time series forecaster that we've been doing in statistical model, you can kind of input Y into the model, and it will just work because it's based on equation. So it doesn't really care how much Y you have. It just do its things using like the past value to predict the future value, right? That's how it works. So you just tell them, this is my past value. Get me the future value. This is okay. Okay?
If I want to predict 5 years in advance in the future of my sales, how much data I need from the past?
Depending on your period. So if you want to do 5 years, then you probably need, also depending on your seasonality. If you only have parts of your season, then you're not going to capture the whole season. Right? If you know that your data repeats every 12 months or repeat every 5 years, you might want to have couple periods in your data, so that when it goes on in the future, it's actually repeating the same patterns. Right? But if your data is just like a straight line, right? You only need 3 points, I would say, in order to interpolate the longer straight line. So if you only have trend, I don't think you need that much data.
So
if you only need to do the trend, like just the line, and then interpolate the line to the future, you don't need that many data. But for seasonality, you might need a couple periods to pick it up. But that's still much less than what the machine learning requires. Machine learning is very data hungry. And that's something that you don't have when you do forecasting, right? In the sales data, I don't know how much points you're going to get, right? Usually you don't have much. Okay, but anyway, I digress. I have this many data, right? If I want to do statistical model, I just plug this data into the model. It works fine. But in machine learning model, it doesn't do something like that, right? Because in machine learning model, you got to have X and Y. And in your X and Y, you need to make it into observation and the answer. Like remember we have like flower. We do the flower model, like iris model. You have to have 150 flower observation, right? So you gotta have to format your data in such a way that it become X and Y. That's another extra processing that you need to do. Okay, so let's think about this. In your X, right, you gotta have X1, X2, X3, right, in a matrix, right? Usually something like that. And then so on, right? And then this is the row 1, row 2 to row n, right? So essentially, you gotta have many observations in your machine to input into your machine learning model, and also you gotta have Y too, right? Your answer, right? This is your Y. This is your capital X, okay? As a matrix, this is your Y. So yeah, you have row 1, observation 2, right? And first of all, your time series data, it does not fall into this format at all. Because it's almost like you have one observation, right? And where is your answer? There's no answer per se, right? Because answer is actually yourself in the future. So the way that you would do this is actually you have to pick window size first. Okay, so let's see, I would say my window size equal to 3. So window size. 3, okay? And so then I can do this. I can pick 3 value, right? If I want to do forecasting horizon of 1, right? I have to know that in advance too. Forecasting horizon, that means I want to predict this guy, right? I want to use 3 value to predict the next value. I guess that's a problem statement that I need to decide first. Like what are you going to predict, right? So I'm going to do this. So my x would now be, right? My x would be y1. Right. This is kind of confusing, right? Okay, I should use green. Okay. Okay, so my x would be y1. Sorry, I should have x1 too, right? x1, x2, and x3, right? So for my row 1, right? This one right here, I would have y1, y2, y3, and then my y, which is the answer, should be y4. Oh, I should use this one. Okay, that's the row number 1, right? For the next row or the next observation, I have to do this. So row 2, right? I would do another window. I shift my window to 2, 3, 4. Okay, so I have y2, y3, y4, and I'm actually predicting y5. Okay. Okay, and the windows kind of move, shift. You know, it's called the step size. If my step size is equal to 1, then I gotta move my windows to here, which is it's gonna be row number 3. That's gonna be my y3, y4, and y5, and then I'm gonna predict y6, and so on. So first of all, in order to do machine learning, you gotta format your data from a time series into like an observation type, observation based into the matrix first. So that's it's a parameter that you need to choose in advance. Okay. Okay. So and then you can plug this. So if you have this, then you can plug this into your machine learning model using scikit-learn model. Once you have x and y, the rest is similar to what you already did before the midterm, right? So that's fine. But there is also another complication because once you want to predict what happened if you want to make, so let's say I want to do this. This is my test data. So from my y11, y12, and y13, that's going to be my test data. So this is a train, right? This is a test. Okay, so essentially I have up until y10, right? Because my test data go into y10. So this one is going to be y9, y8, and y7. I don't know which row it is, but that's how much training data that I have based on this specification. Okay. Okay, so, but if I want to predict the test data, what do I do? Right? Because my model actually needs 3 points to predict the next point. So I got to do my test data in sequence. I cannot do it all at once. Like before, remember before when you were building machine learning model, you would just say, this is my X test and give me my Y test all in one command. Because you can do everything, because not all the data is related. But not in the time series way though. In time series, you cannot do everything all at once. You have to do it in sequence. So this is what you need to do, right? So you need to pick this window right here, right? So you want to do y, sorry, right, you have to do this one. So y8, so let me just see. I want to do prediction, right? Okay. So when I want to predict, I want to do this window right here. So y8, y9, and y10. And I want to predict y11. Okay? Right? So I got my y11 here. Okay? So what about my y12, right? I can also do this, right? I can do y8, y9, and I can do I have to do y9, right? y9, y10, see, and but down my y11 is actually here. And I want to predict y12 prime. I got my y12 prime here. So it works here. And then I have to shift my window again to be y10, y11. So actually my y11 is actually the orange one. Y. And then my y12, and then my y13 prime. So, okay. And I want to make this split because actually I'm predicting. This one is predicting here. Like I'm using all of this. This is my model. I'm using all this, and I'm using all of this to predict this value here. And if you want to calculate MSE or any the test metrics that you want to use, you're actually comparing these two data, right? These two guys right here. And that one gives you MSE or MAPE. See? So you see how complicated this is? Because first, you don't want to be using the yellow, the purple value. If you use the purple value, it's a different problem. That's called rolling update problem. It's completely different from what you want to do. If you want to do like forecasting horizon, you got to make sure that you are not using the purple value. And I've seen so many people using the purple value. And then and that's why the result is too good to be true. Sometimes you can do machine learning and you get good results. But I would argue, be careful. If you're using the purple value, your result will be too optimistic because you already know the test data. But you cannot know the test data. That's the premise of the test data. Test data is the future. You have no way to access the test data. So you gotta make sure that you use yellow value only. But then it's so easy to make these mistakes because you are doing this thing in sequence. You have to keep track. Oh, this is my yellow value, and then you have to inject your yellow value back into your X, and to produce another yellow value. But then in the end, you gotta compare yellow value to the purple value to get your MSE. That's so many steps to make mistakes, and I've seen code that make that mistakes a lot of time. So this is okay.
So yellow is like the most realistic value?
The yellow is the predicted value, the forecasted value, and the purple is the ground truth. Yeah. So when you have to do things in sequence like this, it's very easy to pick this purple value and input it in here. If this is purple value, then this is a completely different problem. This is called rolling update forecast, not the forecasting horizon thing. Okay, so.
Can I also calculate pessimistic values?
Pessimistic value? What do you mean pessimistic value?
Because purple is optimistic?
Yeah, if you're using.
It's another problem.
Yeah, so maybe this one you can say is, I would say it's realistic value. But then if you use this purple value, it's cheating because you are using the value that you're not supposed to know, right? So that's why. But the whole process it's prone to error. It's very, like even right here, it's kind of complicated enough, right? And I've seen model that's actually, if you want to do forecasting horizon of maybe not 1, but 2, then you got to do this one, skip 1, this one, skip 1, and now things that get totally like ridiculous in your code and just spaghetti code in there. So this is what scikit-time tried to avoid. Like it tried to have a really nice API so that you don't make that mistake. And you'll see how easy it is, like incredibly, like stupidly easy it is to make all of this works. And if you see my code, it's really short, by the way. All right. Okay, let's do all of this in sctime library. Okay, and that is the big win. Like even for me, like I can tell that I might make these mistakes too if I were to do it like manually. Okay. Okay, so let's do c1.ipynv. Wait, what is it? Oh, okay. So first, let me just load everything. Run. Okay. And next stop. So these are from the mostly scikit-time. Oh, actually, wait, what is this? Where is my machine learning? Oh, okay. Wait, why is my learning? Oh, right here. Okay, I missed this one. So this is the machine learning model. It's called gradient boosting regressor. So this one, it's the tree base. So this is where I tell you that this is like a forest with the tree that keep learning from one another. So this is one of the kind of like the more advanced tree-based machine learning model. Okay, and the rest is from the sctime. Okay. So first of all, I want to do same thing, right? I want to do airline data, and also I want my forecasting horizons to be just 36 points, right? So again, if you want forecasting horizon to be 36 points, when you do the prediction, you got to do this 36 times in sequence, though. You cannot do it at once, like it cannot be at the same time. You have to keep making sure you have all the yellow value at the right place, okay? All right, so what I want to do is, first I want to build the machine learning model. So I want to do gradient boosting regressor. So that is the machine learning model, right? That's one, I set it to be regressor, okay? And again, you can input as many parameters as you want. This one, I say that max depth equal to none. So that means that I allow my tree to be as smart as it wants to be. Next stop is this part right here. So this part is really cool because I use the function called make reduction, okay? So let's just look into what this function is doing. This is a function though. This is not the class definition, okay? Let me just search in the sctime. Okay, this is what I think really, really powerful, okay? So this one is the function that makes the forecaster that you want into a tabular regression, okay? So the tabular regression is exactly what I just described to you here. Make your forecaster input this data, but then inside it's doing this for you into the tabular. So it makes the data that just one line into table. So that's a tabular. So that's what it's doing, right? So I want to make reduction so that I want to make my regressor like get input at the normal times 3 input, but do the tabular things inside. So I input my regressors inside. Okay, so I input this machine learning model into this function so that my machine learning model would do similar things to what we did with the statistical model. But there is also but there's already a transformation like this happening internally. So you don't have to do anything. You just say what you want, and then it's just taking care of this for you, like this transformation for you. Okay. So here, as you can imagine, I would have to do window length, right? Equal 20. Because when you want to do the transformation into the table, you gotta say what is my window size or window length, right? So this function, you can specify what your window length is. So 20 means that you want to make it so that you get 20y to predict whatever the next value is, right? So you have 20 features, for example, in your machine learning model, okay? And the strategy is called recursive. So that is the strategy that I mentioned here. Like you can keep shifting things, one by one. It's called recursive strategy. There's another type of strategy that you can try. I kind of forget what it is. We can look it up later. But well, let's use recursive for now, okay? And that's it. You're done, okay? And you just put this into forecaster. You're done. See, with these 2 lines, actually just 1 line, like this make reduction line, you already turn your machine learning model that kind of accepts your tabular data into the model that actually accepts just a time series data. And then inside, it will do automatic conversion of your input for you. So you're done. The rest is the same as before. Fit, predict, done. See how easy it is? Like you don't have to do anything. This is so easy, right? So the next step, I'm going to fit, right? Forecaster.fit. And see what my input is. I just input y train. I don't have to do any conversion at all. Just input the regular time series data into it, right? And what's even cooler is that when I want to make a prediction, I just do predict, right? Forecaster.predict with the forecasting horizon. And behind the scene, it would do this for me. Like all of this taken care of automatically. Like it will make sure that you use the orange data only. Never use, I guess you didn't even input the purple data into it. So you're fine, right? When you do the predict, there's no purple data in here. Your purple data is called y test. You don't even use it here. So there's no way you can make that mistake, right? You're done. There you go. Okay, and then I don't have anything else to show you except the fact that I can just plot for you, right? Done. This is the machine learning. So, I mean, if you have to do this manually, it will take a long time. The code will be much harder, right? The logic is actually quite hard. But this make reduction function is magical to me. Like this one is the best thing for me. Like because I had this pain point for a long time until I discovered this, and I never make that mistakes again. Just make reduction. I'm done, right? Okay, so hopefully I convinced you to use this library, right? It's really good, right? Another thing that you can now imagine, like you can see, is that this is the result. We are actually using quite advanced machine learning model, right? Gradient boosting is quite advanced. And this is the result we got, right? This is pretty bad, right? As you can see. The things about machine learning is that in order for you to predict any fluctuation, you need a lot of this. This is not enough. You gotta have more, man. You gotta have more. Because think about this. If you have window size of 20, like 20 points, for every 20 points, right? And then that's your row. Like, I guess the number of rows that you have is actually not that many, maybe like 100 rows or something. And that's too little. But you gotta have more data in order to predict something, right? So, and especially for time series, it's kind of hard to get data, right? How far back do you want to go? You want to go back to 1900? It's kind of impossible, right? So that's kind of limitation why machine learning model doesn't do that well in forecasting because of the limitation in the data itself, right? But if you use the statistic model, you can say, I want my season to be 12, right? I want my trend to be additive, and it just do things pretty nicely, right? So that's the thing. Like I encourage you to try. Like you can try, changing the model around. Right? You can try, making, I don't know, do a lot of things in here. But eventually, you will see that you will always end up with something like this, not like perfect ups and downs as in the statistical model. It's quite hard, actually. Okay, you can if you want to try, you can do something like this. You can pick any of your favorite model. For example, maybe I want to do k-nearest regressor, like the KNN model. I don't remember the name, KNN regressor from sklearn. I want to do this one, k-neighbor regressors, right? sklearn. I have to remember where it is. I want to do neighbor. Okay, sklearn.neighbor. Import this guy right here. And let me just try this one real quick. So all I need to do, I'm just change this one to be that guy. I'm done. See, I want to change my machine learning model, so I need to do. Okay, just run it. Okay, so k-nearest neighbor is actually not that bad, right? So, but then it still kind of miss a lot of things in here, right? It looks too clean. So the trend, it's kind of hard to do too. Okay, so maybe I can try support vector machine, right? SVC from sklearn. Okay, so it's going to be sklearn.svm. Okay, so so you can go back to look at your code and see when you import like sklearn.svm, import svc. Okay, so that one's the one I want. So I want to do this guy, so regressor, right, equal to svc. There you go. Run, done. Oh, actually, I made mistakes here. Did I do something wrong? I'm not sure what's wrong in here. Okay. Oh, so SVC has a little problem with make reduction because it is missing some of the functions in here. So I guess this one's not working. But you get what I mean, right? So most of the sklearn library model should work in here. So you can just instantiate it, put it in here, and then you can just try different things, okay? So if you want, you can go back to your machine learning folder and get some of the model, plug it in here to see what happened. I want to see if you can actually figure out the one that's actually better than ARIMA. So right now, our best model is ARIMA, right? It's fitting pretty well with the airline data, right? Okay, so I'll give you a couple of minutes if you want to try. I'll try it on my own too. I want to see what else I can try. Okay, I want to see maybe, oh, actually, wrong one. I have to use SVR, not SVC. SVR, I need regressor, not classifier. So my bad, sorry. It should work, Regressor equal SVR. Right, sorry, that one should work. Yep, it works. Okay, so support vector regressor is pretty bad. See, like you can't even do anything, right? Okay, let me see what else I can try. I can try random forest, right? That's a many popular model. I've seen a lot of you guys do random forest in your research, right? So random forest regressors in scikit-learn. Okay, so I have to do ensemble and random forest regressor. So from sklearn.ensemble, import random forest regressors. And again, I want to do here.
Did you also try to use the meta forecasting model, the Prophet one?
Prophet? I actually tried, but I didn't install it in here, so I cannot run it for you. What I recall is that I could not get it to be as good as ARIMA, but it probably because I don't understand the model, like the parameter that well, so I didn't adjust it. I guess I didn't tune it to be as good. But
you said it assumes nonlinear trends.
Yeah.
What does it mean exactly?
A nonlinear trend is so typically this data, if the trend is probably like the average of this, right? So it probably go like this. And this one is relatively linear in a way that if you make a difference of the data, it goes into stationary eventually. So here. right here. So here I'm showing you that if I were to do my y.diff, so that means if I subtract 1 from the one next to it, that's a difference, right? So that's how you remove the trend. If you diff it and then it goes into something that is stationary, that means that it's kind of flat, then that means the trend is linear. But if you do the diff, but then you can kind of see something that goes up and down, but not the season though, but like the overall movement of your whole data, it kind of go up and down. And then if you keep diffing your data and it doesn't go away, that means you have the nonlinear trend. And that's probably the whole purpose of like a profit, for example. Yeah, I never tried. I tried it, but I didn't go into the detail, so I couldn't tune it to be as performant. So AutoArima is, from my experience, AutoArima, it's always give me the best result. Like just plugging in AutoArima, it usually turns out okay. Mm-hmm. All right, so I try a lot of things in my machine learning model arsenal, and I couldn't get it to be as good as Arima. Okay, like this is random forest. Okay, so I made my point. Okay, if you want to do machine learning, make sure you have lots of data first, or else you're gonna be at a disadvantage. For example, like this. Okay, all right. The next step is that if you think that this is complicated enough, now if we have exogenous data, I don't even want to draw the schema to do exogenous data. It's even more complicated. So exogenous data means that you have another variable that you need to use in order to make prediction and training, right? So let's just imagine that you gotta make sure that, okay, if you have exogenous data, you have to include them into each of the rows correctly, right? If you have another x in here, you have to make sure you have another x in here, that you have more features in here. And you have to make sure that when you're doing the prediction, you get the right one too. So it's added complexity into your pipeline, right? I just want to let you know that, show you that, if you use scikit time, sk time, it's actually stupidly simple as well. Okay, let me just show you this. Okay, so next up, I have this code where I have, I guess, same data. Okay, I'm using the gradient boosting regressor as well, and airline. Okay. Okay. Again, if I do plot, right, this is the data that I want to forecast. But then let's say that I have another data that I think might have some correlation with the airline data. So this one right here. So this one I just made a random X just to include into the model in case it might help my model. Okay. Okay, and then I want to split them so that you have train and test. So I have y train, y test, x train, and x test. Okay, but keep in mind that this y and this x is actually not the same y and x in your machine learning model. This y is your data that you want to forecast, and x is the exogenous data. So different concept. This is time series, not the tabular data. Okay, not yet. Okay, and I want to do forecasting horizon to be 36 as well. Okay, so this one, nothing changed yet. Okay, so here's the thing. If I want to do x in here, all I need to do is just the same thing. I make a regressor, right? And then I want to make my reduction. So this one, I'm turning my machine learning model into kind of the time series model so that it can do all this transformation inside, okay? The cool part of this is that if I want to include my X data, I don't need to do anything else apart from forecaster.fit, right? And then do y train, right? And then x equal x train, okay? Just this part right here. This part will make it so that internally, it will format all your y data, your time series data, including your exogenous data, make it into the correct tabular format and input that into your machine learning model. Like all of that done behind the scene for you. That is so cool. Like I've never seen anything so easy like this. Okay, let me make sure that I did it correctly, okay? But that's all you need to do. Just, yeah, right here. Include the X in here, okay? And once you're done fitting, then you can do forecasting. So forecaster.predict, right? And I want to do forecasting horizon, 36 points in the future, with my X equal X test. Done. Okay, I can do Y predict equal. Okay, and if I were to plot them, then yeah, I can plot them. Why not, right? Yeah. Again, I don't expect this to be better, right? Because my exogenous data is just a noise. It's a random noise. So it should not help my prediction, which is, I guess, expected, right? This one looks similar to what we had before without the exogenous data. But hopefully, if you use something that correlates with the, your data, for example, the holiday, it might actually help machine learning kind of detect the peaks. I think it might. I've seen people do that, right? They make like 1 and 0. 1 if it's holiday and 0 if it's not holiday. And that kind of data might help the machine learning algorithm, okay? But again, remember last time I was telling you before we left that this is wrong, right? This is wrong. And it's wrong because of this part. When you predict something, if you're using the test data, that means you are prophets, right? That means you know the future. You're not supposed to use the testing data when you are predicting. That's wrong, right? So, and I was telling you that actually the right way to do is actually to predict exogenous data first and use that data to predict your actual forecasting data that you want, okay? And all of that is actually even more complicated when you combine with machine learning algorithm. Like all of that, I don't even want to code that seriously. Like all of that is just too much, right? But again, if you were to use skTime, everything is done by just including one step. Let me just show you this one, okay? The first one is the same, except for I was using this part right here, forecast X. So this one is a wrapper around the forecaster such that it can help you forecast your X using variational autoregressors. Remember, at the beginning of this class, we're using VAR to predict multiple value at once. So that's perfect for your exogenous data. So when you are going to predict your Y, your sales or your passenger number or airline passenger, you have to predict your X first in the future and then use that X to predict your Y. So that's how we do it, okay? So just this one line, that's how you solve all of that problem, and then all that complexity just goes away, okay? And this is the right way of doing. I cannot. See? And again, I don't expect this to be better, right? Because my X is just a random noise. But I cannot stress enough how easy this is. Like this is so easy compared to the complexity that you have to go through. So again, I guess in the end, if you can, use this library, okay? And if you want to code things by yourself, by all means do, right? But at least you have something you can compare with if you want to check if you make mistakes, because it's really easy to make mistakes when doing this time series, especially with machine learning, okay? All right, so that's all I have for time series. Next stop should be artificial neural network, but we only have half an hour, so I think I will just skip until next time, all right? I think you guys are tired already. Okay, see you. Yeah.